Hey everybody, welcome to week three. I just wanted to go over a few of the concepts from the slides from this week. In my other video, I'll show you how to use filters in Tableau. And if you received feedback from me in week one saying you want to avoid scroll bars in your dashboard, that's what the one way to go about doing that is use a filter to filter that data down. We'll also get into table calculations, and then I'll show you how to make waterfall and Gantt charts, and then I'll cover some dashboarding tips as well. This is a slide I grabbed at a session I was at not too long ago that I kind of had to laugh at. And what made it kind of funnier was one of my former students was actually at this session with me, and he kind of knew my disdain towards pie charts. So this presenter was very well versed in her subject matter, which are, social determinants of health. However, visualizations was not so much her jam. So again, pie charts are not always a bad thing, but one thing you got to keep in mind is in this example, this chart does not stand on its own. Okay. And that's one thing I'll challenge you with quite a bit is, does it stand on its own? So you can't look at this chart and tell me, what percentage each of these slices of the pie are. So that's a big reason this would not be a good chart. This is a graphic I share with a lot of people, students, clients, colleagues of the like, and talking about what our modern data scientist looks like. Okay. Not physically looks like, of course, just what are some of those characteristics. And here's the thing that people get caught up in is you do not have to be an expert in kind of all four of these quadrants, if you will. Okay. Pick one, pick two, be really good at it. Okay. For example, some of these things on here, I'm not good at machine learning, Bayesian inference, decision trees. I'm not a stellar programmer. I can do a little bit, but there are people far better than me. Where do I excel in a few of these areas, right? Fundamentals of computer science, probably databases to some degree. But for me, it's kind of in that lower half there, domain knowledge and soft skills. Okay. There's a reason that the bulk of my consulting in visualization is in the healthcare space. That's where I do my work. I know that domain very well. Not too long ago, I had a construction company ask me to do some work for them. And I had to respectfully decline because it's not an industry I know much about. Okay. And then on the lower right-hand quadrant, communication and visualization. Of course, visualization is a major part of what I do, but also storytelling, being able to engage with leaders is a big part of my skill set. Okay. Just a few other kind of, funny charts I always like to show. Those of you that have, most of us probably have in our lifetime had to purchase printer ink or toner cartridges. Obviously, very expensive. Kind of they're doing a little tongue in cheek here with talking about ink costs more than blood, meaning what a hospital would charge you if you needed a blood transfusion. Here's another one that's kind of interesting that shows the longevity life of animals. What's interesting is I've been using this one for a while, and I read an article just the other day that there is a giant tortoise that is now over 150 years old. So I guess we need a new viz there. I thought this one was pretty good. Talking about how we break down in terms of occupations, from unemployed all the way up to upper management. Kind of an interesting deal that towards the bottom it looks like they're showing like a sweatshirt, maybe like a hoodie, and then at the top, true to form to the stereotype white collar, if you will. Just a couple funnies about songs, shampoo, hey, what I do when I can't hear somebody. Here's a few links I've made available to you. I won't go through each one of these individually. One of them, I'll kind of date myself here. The fourth link down, Mario talks about how Super Mario Brothers, the original game, was created in I think 1984, 1985, and it was actually done on graphing paper. And what's interesting is still to this day, when I go to create a dashboard for somebody, I start on graphing paper. I don't start by opening Tableau or Power BI and starting to throw charts on a page. I think about what I want to represent and I think about how I want to use that space. And then once I get a concept, I'll then take that to my technology tool to create it. Okay. Okay, so from the data points text, just a few things I wanted to kind of call out. We always need to give thought to our scales, okay? And things, different ways to scale things. Obviously, linear, straight line, logarithmic scales. I'll be real honest, I use very, very, very little logarithmic scales, simply because they confuse most people. Most people don't understand what a logarithmic scale is, and that's okay. We play to our audience, okay? Things like ordinal, categorical. The thing to keep in mind about categorical and ordinal is I can also come back and associate quantitative values to this. Okay, and let me give you a great example. When I think about the student survey or evaluation that you will all fill out at the end of this class and with all your other classes, you will be asked to rate my performance as a faculty member on an ordinal scale. So you'll answer a question like, how was Dave's overall effectiveness as an instructor? And you might have the option of highly effective, effective, neutral, somewhat ineffective, very ineffective. Okay. And we can associate numbers to each one of those. And what that enables us to do is we can quantify after that. So what I get when I get those survey results back, I don't see your individual surveys. They truly are anonymous to me. But what I do get to see is I get to see a summative result. Okay. So they do associate numbers to those, and I get a total score. So I don't see how each one of you rated me, but what I see is on a scale of one being the lowest, meaning very ineffective, to five being highly effective, I get a score. Okay. So for example, anything above four is considered pretty good. So if I see a 4.5, that means that the majority of the class felt I was highly effective in what I did. Okay. As I stated earlier with the Mario game, work often starts with rough sketches on paper, dry erase boards, and then moves to exploration and production again. So it's okay to be a little analog here and start on paper. Like I said, I've still got a desk drawer full of graphing paper and really some crayons, and that's kind of how I start from time to time. Okay, from the data fluency text, just a couple of things. When we think about we live in this deluge of data, right? So data is everywhere. We're swimming in it in every single industry. We've got more data than we can possibly decipher at once. So how do we move this from the useless to the useful? Okay. So instead of things like Excel and CSV files, purchase history, survey results, how do I take that to dashboards, KPIs, okay? Files that actually give me insight, tell a story. Okay. The other thing we do a lot of, and it seems like the deeper we get into this, the worse it gets, is we get overloaded in some of the jargon. Okay. And I'll be the first to admit academics, my people, are some of the absolute worst at this. Okay. We hear people use terms like correlation all the time, and they don't really know what it means. Okay. Keep in mind, correlation is not causation. Okay. Let me give you a really good example of this. So, when weather conditions are favorable for a hurricane in hurricane um, prone areas of the United States, okay, when the probability of a hurricane is incredibly high, Walmart notices an interesting phenomenon. When a risk of hurricane is imminent, Walmart sells substantially more Pop Tarts. Does that mean that if Pop Tart sales goes up, a hurricane is coming? No. It does mean it's correlated, but it's not a causation. Okay. So keep those things in mind. Statistical significance. If you put on your stats hat and remember your last stats class, one thing we talk a lot about is our R squared when we look at correlation of two variables in relationship to one another. Okay. What is a statistically significant R squared value? And the answer is it depends. Okay. If I'm looking at something like risk of a pharmaceutical product causing an adverse reaction, I want to see a very, very strong score there, meaning 99% of the time it does not cause an interaction, maybe even 99.9. Okay. But if I switch disciplines and maybe I'm looking at marketing, okay, what if I'm in the grocery store and I have bought three things? If I've bought cookies, what's the correlation of me also buying a candy bar? Okay, marketers would love to be able to predict that even 40% of the time. Okay, if you got them to 70%, they would just be giddy with you. Okay, so again, it all depends. Okay, so again, some of these other ones, page 56 really gets into this a little bit more. Okay, something to keep in mind. These products aren't synchronized swimming. Okay, perfect harmony doesn't have to be our goal here. The text uses the example of, well, it's more like water polo. Move the ball forward, stay in your position. Okay, I had a boss a long time ago use kind of a different analogy, and she said, you know, we just got to keep moving forward. We're in low gear. We're not moving fast, but the important thing is we're moving forward. We're not at a standstill and we're not moving backwards. Okay. One area, the text talks about this, and this is really important. One area that I see many people kind of gloss over or don't cover at all is, you know, we take data, we visualize it, we analyze it, and I don't see people do a very good job of talking about where did the data come from? Okay. When was the data collected? Okay. Is the data old? Okay. I had a student not too long ago was trying to basically use a viz to call us to action, but he was using data that was 25 years old on a topic that was very current. And I said, well, your data isn't current. We got to have current data. Who collected it? Okay. This might not seem like much, but this is a really big deal. And let me give you another example. I had a student a few years ago that was showing data on gun violence. Okay. And I'm not here to take a position on this or to convince you one way or the other, but when he showed his analysis, he had a data set around gun violence, and it was very compelling to show that gun violence had declined dramatically. Okay. And when I finally asked him where the data came from, he finally showed me that it was data from the NRA. Okay. Now, do I know that the NRA, National Rifle Association, purposely sabotaged the data? Do I know how it was collected? I don't know any of that. Okay. But they're an organization that has a vested interest in showing that gun violence is not a problem. Okay. Again, not here to tell you it is or it isn't. That's not my discipline. I don't know enough about it to tell you. But the important thing is you got to think about credibility of your data. Okay. So sometimes that might be the only data you have access to. And when that's the case, you need to be sure you address the strengths and weaknesses of your data, because if you don't, I guarantee you somebody in your audience will. Okay. Okay. We think about the skill sets that we have, it is a incredibly rare skill set. We have to have all of these things, right? You know, you have to be that salesperson, you have to be the therapist, the connoisseur of the data. I'm kind of, you know, pushing it a little far here, but again, you don't have to be good at all of these things. Okay. My former business partner was really good at the analysis, whereas I was really good at the sales piece of it. So she would do more on the analysis side, and I would do more on the sales side of it. So find somebody or somebodies that complement your weakness. Okay. So if you're not good at a certain thing, find somebody that is. Okay. And this is one of my favorites. Data isn't like your kids. You don't have to pretend to love them all equally. Okay. Let me give you a great example. I was working with a health department not too long ago, and they wanted me to analyze a bunch of their data. So one of the data elements they wanted me to look at was clinic visits. So they wanted me to look at the type of visits that came into their clinic, meaning, you know, health departments do a lot of things where they do um, newborn care, they do vaccines, they do STD testing, they do prenatal care, those sort of things. So to me, that data is fun. It's exciting to look at and see where they do the most of their work at. I loved it. The other data that I had to work with that was more of like the stepchild of data, if you will, was they also had to do reporting to the state on people's ability to pay. So naturally, they treated a lot of low income people. So you had to analyze this data, put them in a sliding scale income bracket, put it in this nasty Excel template, and then upload it to their website. I detested it. It was no fun. I didn't enjoy it at all, and that's okay. But it's still a necessary evil. Okay. All right, couple things to think about. One thing I tell my undergrads all the time is the most dangerous phrase in business is we've always done it this way. So sticking with those historical conventions on how we do things, okay? Things like overly simplistic metrics, all right? There used to be a car commercial on, I think Honda was the company, and one thing they talked about was 4 out of 5 Honda owners would purchase a Honda again. Incredibly simplistic, right? Why? Why would they do that? Okay. Or overly complex metrics. If you want to see overly complex metrics, turn on a major league sporting event. Data has exploded in this space. Okay. Just recently, I was watching a baseball game. It was down to the ninth inning. The score was tied. Their leadoff hitter was up to bat. And what happens? The announcer says, this particular batter has a 47% chance of getting a base hit in the bottom of the ninth inning with at least when there is at least one runner on and there are 1 or 0 outs while it's a home game. What? Okay. It's way too complex. Okay. Too many metrics that don't add value. All of those things are things you need to think about. So those are a few of the topics for this week. So keep that in mind and also check out the other lecture where I actually do the Tableau work as well. So as always, let me know if you have any questions.